Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture, and in this video lecture we will derive the nth order derivative of this function e raised to the power ax sine bx plus c. This function composed of product of two functions, that is exponential function and trigonometric function. So we will derive this is simple exponential function, this is simple trigonometric function. So we are asked to find its successive differentiation, that is nth order differentiation, that we will try to find the nth order differentiation of this function. So we know that to find the nth order differentiation we must find its 2 or 3 order derivative, then try to generalize. So we'll see how it will be done. Let us differentiate it with respect to x. So what we'll get here will be y1, and since it is composed of two functions, say this is function number 1 and this is function number 2. So you know how to differentiate it. Differentiate, let us say I differentiate first function. Differentiation of first function will be this one. Second function will be same, sine bx plus c. Now next I will keep the first function as such, and differentiation of sine is cos bx plus c into b. From here I am going to take e raised to the power ax common, so this will be a sine bx plus c plus b will come over here before cos bx plus c. So I am going to close the square parenthesis. Fine. So now so as to generalize, we have e raised to the power ax here is e raised to the power ax, but we don't have sine here, so that we could generalize to some extent, but we don't have that same term that could lead us to the generalization. So we instead we have a sum of sine and cosine term. So this is not possible from here to generalize. So we need to modify something so that we could put it into sine form. But we know one formula, you remember, you know that sine a plus b is nothing but equal to sine a cos b plus cos a sine b. Fine. So here sine is present. So if I want to make it as formula for sine, here sine is present, here you need to put the cos, and here cos is present, you need to put a sine. So I am going to assume a as r cos alpha. Now you remember that you should note it over here that I have put here cos because I am targeting the sine formula so that I could generalize, because here is sine, so here should be sine. So that is why I have put r cos alpha, not r sin alpha. Otherwise I could have also put it as r sin alpha, but what I have put it over here r cos alpha, and b could be put it as r sin alpha. Fine. Now scaling and adding both sides, what will get? You will get a square plus b square is equal to r square. Fine. This implies that taking square root on both sides, r is equal to a square plus b square square root, a square plus b square square root. And when we divide, say this is equation number 2 and this is equation number 1, when we divide 2 by 1, what we get? We get r sin alpha divided by r cos alpha is nothing but equal to b by a. R to r will cancel out. This implies that tan alpha is equal to b by a, implies alpha is equal to tan inverse b by a. Fine. So we have this one, and you may name it as equation number 3. You may name it as alpha as equation number 4. So now we will put it over here in equation. You can name it as r strict. So you will put it over here. So what will get? It will be y1 e raised to the power ax as such. It will be r cos alpha sine bx plus c plus r sine alpha cos bx plus c is equal to r e raised to the power ax cos alpha sine bx plus c plus sine alpha cos bx plus c, which is nothing but equal to r e raised to the power x. Now use the formula. This will be sine a plus b. It will be sine bx plus c plus alpha, and you are going to name this equation as equation number 5. Now from first order derivative we cannot generalize. This is as simple as this. From here we are not in a position to generalize. We at least need second order derivative so as we could generalize from here. So we have no option but to differentiate it again. So we will now differentiating again, we will get it will be y2 is equal to r will be as such. Fine. Now again assume as first function, second function. So I am again doing the same thing. I am differentiating e raised to the power ax first, then we will be differentiating. It will be e raised to the power ax into a. It will be sine bx plus c plus alpha plus it will be e raised to the power ax now as such into sine differentiation is cos bx plus c into b. Now you will take e raised to the power ax common, and we will again put in place of a you will put r cos alpha, in place of b you will put r sin alpha. So I am going to take e raised to the power ax common. So what will get? You will get y2 is equal to e raised to the power ax common. Fine. R is there, and here I am going to put r cos alpha sine bx plus c plus alpha plus r sine alpha. It will be cos bx plus c plus alpha and close the parenthesis. Now take r common again. It will be r square e raised to the power ax. It will be cos alpha sine bx plus c plus alpha plus sine alpha cos bx plus c plus alpha. Fine. So this will be r square e raised to the power ax. This will be sine bx plus c plus alpha, and once again a plus b formula. This is a and this is b. Here will be plus alpha. So this is equal to r square e raised to the power ax sine bx plus c plus 2 alpha. Now this is your y2. Now we will try to generalize. Look over here. When here is 2, r raised to the power 2. When here is 1, r raised to the power 1. So whenever here will be n, so here will be n. And you see here is sine, and here is also sine. So y means y naught. So when here is 0, r raised to the power 0 is 1. So I am going to put similarly, I am going to write the nth order derivative yn is equal to r raised to the power n. Fine. And e raised to the power ax is here present also here. It is also here and it is also here. So in nth order derivative it will also be present. When here y is n is 2, bx plus c plus 2 alpha. Fine. When here is 1, bx plus c plus 1 alpha. Here it is nothing, so we can take it as 1 dot alpha. Fine. Here it is 0, so it can be treated as y is equal to e raised to the power ax sine bx plus c plus 0 dot alpha. So when here will be n, so what it will be? It will be sine as such, because here is also sine, in second order also sine, first order also sine, and 0 order also fine. In nth order it will be sine. It will be bx plus c plus n times the alpha. Fine. So this will be nth order derivative, and you know the value of r. What is the value of r? It will be r is a square plus b square raised to the power 1 by 2. Square root can be written something like that. So I am going to put this value over here. So what will get? A square plus b square n by 2 e raised to the power ax sine bx plus c plus n times alpha. What is the value of alpha? Tan inverse b by a. So I am going to put it as tan inverse b by a. So fine. So this is yn. So this is the value of nth order derivative of e raised to the power ax sine bx. So I am going to put it into box. So this is the required nth order derivative of y is equal to e raised to the power ax sine bx. So you will just go through this one, and in this we have derived the nth order derivative of this one. On the same lines, I am leaving it for you, and you will do it and will send me through WhatsApp or whatever mean by scanning your answer. So the exercise question is, you have to find the nth order derivative of y is equal to e raised to the power ax cos bx plus c. So here I am dropping the hint that you will differentiate it first time on the similar lines. So there you will get, I am writing it over here, you will get y1 is equal to a e raised to the power ax cos bx plus c, and e raised to the power ax as such, this will be sine bx plus c into b, and also here is minus, so I am going to put it over minus, because differentiation cos is minus sine. So e raised to the power x can be taken common, so it will be e raised to the power x common. So what you will get? A cos bx plus c minus b sine bx plus c. Now you will try to make it as cos, and you know what is the formula for cos a plus b. So can you help me? It will be, you know, it will be cos a cos b minus sine a sine b. So you will put here, you have to make cos with cos. So here you will put a, again a is equal to r cos alpha, and you will put b as sine with sine, so be a sine r sine alpha. On the same lines you will do, then you will again differentiate, and on the same lines you will do, difference is here will minus come, and that minus will be absorbed in the formulae of cos a plus b. So similarly you will derive, and the result will be same. Instead of here is cos sine, so in that formula you will get here as cos, you will get there as cos instead of sine. So rest will be same. So I leave it up to you to derive that particular formula and arrive at the nth order derivative of this one, and will send me after scanning it. So that's all I have from this lecture, and in this lecture we have studied the nth order differentiation of two elementary functions that compose a product of exponential and trigonometric functions, and that these functions are important so as to solve the differentiation of the given functions in the problems. So that is all I have from this lecture, and if you like the lecture, please like, subscribe, share and comment. I would recommend you to subscribe the channel so that whenever there is any update on the channel, you will immediately get the notification of the same. So I recommend to just subscribe the channel, and that is all I have from this lecture, and I would like to thank you for joining, and keep learning, keep studying, and this is Dr. Rajesh saying you goodbye, take care, bye bye, and see you soon.